Here's a riddle for you. What was the largest ocean in the world before Balboa discovered the Pacific Ocean? That's probably an easy one, but maybe I got you. It's the Pacific Ocean. Whether it was discovered or not, it was still the largest ocean. Alright, here we go. I am going off of memory as far as what page numbers we're on, but in the Cosmic Catalog, I believe this is going to be page number 24, but I do know it's on the back of the last page that we've done, which was the log transformation function. So just look on the back look at your last one in your Cosmic Catalog and just make sure you've got your log, and then on the back of the log page would be this one. And the function family is y equals, and again I'm going off of memory, I think we started with the cosine of x. I could be wrong. Either way, it's fine. Parent function would be the trigonometric functions. So after the activity in class, during our last block period, first block period of the week, we had that the butcher paper, and you were drawing the graphs of sine, cosine, tangent, and we're going to get into specifics of what the cosine, sine, tangent graphs look like here today in the videos. And so we're going to generate the graphs similar to what you guys did on the butcher paper, and hopefully you put thought into that and we're understanding the connection between the unit circle and the actual graph of the functions. So let's go ahead and get started. Functions are always dealing with an input and an output. That's the definition of a function is for each input there's exactly one output. And so we can figure out what the graph of a function would look like just by picking some random inputs and seeing what we get out. Okay, so I encourage you to make an XY chart here, but also, I know there's not a lot of room here, but I want to refer to the unit circle and how it relates to what we're doing right now. Okay, so when I draw my unit circles, I draw the x-axis and the y-axis, and then the big three, I call them the big three angle measures in each quadrant. And you know, the first one is going to be 30 degrees or pi over 6 radians. Okay, so when we divide the top half of our circle, just as a quick reminder, divide the top half of the circle into 6 equal sections. The first 6, that's 1/6 of the way to pi, so pi over 6, 1/3 of the way to pi is right here, or 2/6 pi, and we call that pi over 3, and so forth. Okay, well, regardless, we have 0 down here, and we have pi over 2 up here, and remember, if it's a unit circle, then the x-coordinate of any point around the unit circle would be the cosine of the angle. Okay, so in other words, if we just picked 0, okay, so if x is 0, that means 0 radians. We're going to do everything in radians now. As you notice along the x-axis here on the graph, we have radians. It's marked off in radians, and cosine of 0 radians would be the x-coordinate of the point on the unit circle that corresponds to the angle measure of 0 radians. Well, the coordinates of that point are 1, 0, and the cosine of that angle, 0 radians, is the x-coordinate of that point, so 1. So we already have the ordered pair, or an ordered pair on the graph of y equals cosine of x. Okay, and so let's put 1 right there, and let's put -1 right there, and let's put a point. Alright, so 0, 1. And then the next easiest one, kind of hard to figure out where radical 3 over 2 is, but let's pick pi over 3. And when we look at the x-coordinate of that point, we know that the x-coordinate is 1/2, so the cosine of pi over 3 is 1/2. And then let's go all the way to pi over 2. And if the input is pi over 2, we know that the output is 0, because the cosine of pi over 2 is 0. Okay. Now remember, the cosine is always the x-coordinate of the point on the unit circle. So if we travel, if you will, from the radian measure of 0 to the radian measure of pi over 2, the x-coordinate continues to get smaller. So if you look at the x-axis, any point as the points move along the unit circle from 0 radians to pi over 2 radians, the x-coordinate of the point on that unit circle gets smaller. And so if you think of it that way, you don't really need this stuff. You can just go, okay, well, from when cosine is 1, it's going to go all the way down to a cosine of 0. Where is it, cosine of 0? Well, it's cosine of 0, right, the cosine is 0 right there. Okay? And then we can travel, let's see, pi over 3, well, that's a third of the way to pi. So pi over 3 to pi over 3, third of the way to pi is right there. Okay, and then the y value is 1/2. Okay, and so we don't really have very many, but we do know that it decreases gradually from, I missed it, decreases gradually from 1 to 0. Okay, so it's going to look like that part of the graph. And then when we start here at pi over 2 and we make our way all the way over to pi, excuse me, we can pick the next most convenient value, 2 pi over 3, and we get 1/2. We can pick pi, and we get, what's the cosine of pi? That's the x-coordinate of that point, -1. Okay, well, we know that when x is pi, y is -1. And when x is 2 pi over 3, y is -1/2. And so we get, again, the gradual increasing in the negative direction of the x value, of the x-coordinate. So any point, if you travel from the pi over 2 radians all the way to pi radians, and you want to really try to understand what I'm doing here. Think about the x-coordinate of any point along the unit circle here, going from pi over 2 to pi, getting bigger in the negative direction. So it's getting bigger in the negative direction. It starts at 0, and it goes all the way to -1. And that's as low as it can go. That's as far left as any point on the unit circle gets. And so we continue with the curve here, and we just gradually, and this is what you guys were doing in your project during class, is finding more and more specific values in between the 0 and the pi, and then so forth. So if we continue with that, basically the graph continues in this pattern, going from pi to 3 pi over 2, going from -1 all the way to 0. Okay, and then finally when you go from 0, or 3 pi over 2, all the way to 2 pi, then the x values, or the x coordinates along the unit circle here, are getting bigger. Okay, and so therefore, and they end up at 1. When x is 2 pi, the y, or the, sorry, when theta is 2 pi, the x-coordinate is 1 again. So we get back to the 1. And that's what the graph looks like from 0 to 2 pi. Now if you think about this, once you're at 2 pi, you're basically starting over. Okay, so this shape right here represents a shape in which it's one period of the sine function. And a period of the sine function would be how long does it take for the graph until the graph starts repeating itself again. That's what the period means. Okay, and we'll talk more about that part in class, but that's what you should know, that from 0 to 2 pi, that is one full period of this particular function. Okay, well, if that's the case, if we go backwards, we could do that as well. We could find some values, but if we go backwards, we see the same exact shape. And let's go ahead and just pick a couple values, just so that you're not just kind of randomly doing this. If we look at the graph of the unit circle, and we pick the x-coordinate of -pi over 2, that brings us right down here at the bottom of the circle, and we know that the x-coordinate is 0 there. If we go all the way around the circle to the other side, we know again that's -pi, and the x-coordinate of that point is -1, and we can go to -3 pi over 2. we get an x coordinate of negative 3 pi over 2, the y coordinate, sorry, the theta is negative 3 pi over 2, and the x coordinate of that point would be 0. So we're right back up here at the pi over 2 value, angle, and the x coordinate of that point is 0. And then negative 2 pi brings us all the way back around to the beginning, and we know that the x coordinate of that point is 1. So if we plot those points, we can see the pattern here. Okay, negative pi over 2, 0, negative pi, negative 1, negative 3 pi over 2, 0, and then negative 2 pi, 1. And so we can go backwards. Same thing. It's easier when you draw the whole graph at once. Okay, and so there you see 2 complete unit circles worth of values in which we can use to graph the cosine of x. And again, just want to reiterate that from 0 to 2 pi, I should have brought that all the way down here. From 0 to 2 pi, that's one period. Okay, well, from negative 2 pi to 0, also a period. So we start at 0, and how long does it take for it to repeat itself? Well, it takes 2 pi radians. And we'll fill that out in the chart down below. So let's go ahead and take a look. The domain of the cosine of x is all real numbers. The range of the cosine of x, you notice that it doesn't get any lower than negative 1, and it doesn't get any higher than 1. The y values. Remember the domain is the x and the range is the y. So the y values don't get any lower than 1, and they do include negative 1, and they don't get any higher than positive 1, but they do include positive 1. Increasing, this gets a little tricky how we write this, but if we're just talking about on the interval from 0 to 2 pi, then the graph of the cosine of x is increasing from pi radians all the way to 2 pi radians. So we're just going to focus on the first period here from 0 to 2 pi. Decreasing also on the interval from 0 to 2 pi would be from 0 radians all the way to pi radians. Okay, well, we don't see any dotted lines, and we don't see the graph approaching any particular horizontal line, so we don't have any horizontal asymptotes, and we don't see it going up or down to positive or negative infinity, so we don't have any asymptotes here. Now the x-intercepts, well, as you can see from 0 to 2 pi, you know what, I'm not going to do that. I'm going to, let's acknowledge all of the x-intercepts. It would be a good thing to be able to write. So we start with pi over 2. Start with pi over 2, and if you look at the graph, what do you have to add to pi over 2 to get to 3 pi over 2? Sometimes it's easier to see when you start at pi over 2, you can see you can add pi, and then add pi again, and add pi again, add pi again, or you get subtract pi and subtract pi. So the x-intercepts can be written like this: pi over 2 plus some arbitrary integer times pi. That takes care of every one of them, in which k is an integer. This is helpful to be able to write this, by the way. It's going to help you later on. So every time we see k, we know that we can replace k with any integer, so the integers 0, 1, 2, and all the negative numbers as well, 0, negative 1, negative 2, and so forth. So if k is 0, then we have pi over 2. If k happens to be 1, then we have pi over 2 plus 1 pi, which would be 3 pi over 2. So that takes care of the first two. And then if k is 2, then it would get the next one. K is 3 gets the next one, and so forth. And so the easiest way to write that is in that form right there. Okay, I'm at 14 minutes. I got to get this done in 15. Y-intercept, we can see that the y-intercept is 1. The maximum value is 1. Minimum value is negative 1. And the periodicity, this is just like I was mentioning before. What is the period of this function? Well, it repeats itself every 2 pi radians. And so 2 pi is the period of the cosine function. And there you have it. I will see you in the next video.